Good evening, y'all. Welcome back to another Electronics Bash Sunday night's Fundamentals of Electronics and Programming stream. I'm Jeff. It's nice to see you all again on this lovely chilly here in Chicago Sunday night. I think even out west where Nate is this evening, it's gotten relatively chilly as the fall is upon us. We're definitely in sweater weather now, and I am just gonna embrace it. As always, we'll give people just a couple minutes to catch up if they're straggling in late to the stream, and we'll do a little preamble. The wildest thing I have to share tonight, to be honest, is my beer choice for this evening, which is it's going to be glary. There we go. The Bold Dog Beer Company's Tilly Reserve Wine Barrel Aged Mango Papaya Hefeweizen. It's good. It's just a little bit weird. It's not sweet at all like a fruit beer normally would be. And is for a wine barrel aged beer, it's only 5% by volume. I don't know. I'm not entirely sure like how I would have characterized it if I didn't know what the heck was going on inside of it, but it's really good. So that's what I'm drinking tonight. I don't know what y'all are having. Oh, Chris says, we're from the Bold Dog, that's B-O-L-D, Bold Dog Beer Company in Chicago, Illinois. I wonder if they're doing some contract brewing with somebody, because I've never heard of Bold Dog, but they have I can't see on that view. They have, a nicely packaged can. There's also this style of sticker can, although it's places like Alarmist local to us have some of this style normally. I find a lot of contract brewers do this because it doesn't require really any special equipment, right? You just order your stickers from a printer and then you slap them on your cans that someone else has filled for you with their equipment. Anyway, that's my most exciting adventure of the evening. Here, stand by 1 second. It's good. It's like if a Hefeweizen and a Chardonnay got together and had a party. Yeah, I don't know. Just having a whole time. In any case, that's kind of like the wild part of the evening, because to be perfectly candid, tonight's topic, which is working with files and persistent storage in Python, is a super useful topic, but I will fully admit, not a super sexy one, or as opposed to making an animatronic thing or reaching out to the internet. Working with files is, I think, a necessary topic, but not a super not a super visual one, honestly, but it's something we're going to have to talk about at some point, because I know in at least 2 or 3 of these I've been we're just going to read some data from a file, we'll talk about that later. That later has got to be today, because these are really useful things to have. Have in your toolkit as you're working with data sets, as you're working with info, and especially if you're working on a code problem that someone else has given you. Teaser, we're going to talk about that at intermission time. Some places where working with files can be useful, and some coding challenges specifically that will make use of them. Yeah, so we'll just run through some things. Not a lot of I don't think any physical demos tonight, which is fine by me. Excuse me. This is a bubbly one. You guys are in for some oral excitement this evening, it sounds like, with this Tilly Reserve. Yeah, kind of a hectic week. Most of you know I work at a big science museum. As of this Thursday, we are closed to the public again because COVID cases are doing their thing in the fall like we all expected they would. So I'm still going in some days a week to get some things done in a giant empty museum. But as you can imagine, the process of shutting things down again has been a little bit crazy. So a week with no physical demos is actually really great for me. But I think the code will still be really useful. So yeah. Let's just dive into it. As always, ask questions as they come up. Throw in your puns. Let me know when I forget to unmute myself, and we'll just get going. Let me show you first off. I'm taking to the Raspberry Pi. This, as always, if you haven't been here recently, we're working in the Thani IDE. Chris says getting things done, aka playing around. There is certainly some of that, but so one of the things we're working on recently is a giant backup project, backing up a lot of the computer systems that run our various exhibits. And there are some of them that we're going to be turning on and off intermittently over the next few months as we go into do virtual content or digital tours. And some of those computers, the more we turn them on and off, especially in non-standard configurations, the more worried I get. So I'm going in to make sure that everything is stable and backed up before chaos. And some fun stuff too. So let's talk just a little bit about how you work with files in Python. Let's just get into it. Here's a really basic structure. And again, as always, let me know if the font is not readable or something, we can make it bigger. The core of our operation here in Python is going to be the open and close functions, which are built-in functions with Python. You notice I haven't imported any additional libraries to do this. I've just used open and close, no, library.open or anything. No, just say open this thing. You give it the file name that you want to reference, and then you give it a string representing the mode you want to open the file in. There are various modes. Let's see. Oh, I've changed the font size here. There we go. And you can see some of them here. Mostly what we're going to be using is R or W, which, as you might guess, stand for read and write. There's also exclusive creation. So it says, make this new file unless it already exists, in which case don't do anything. And A for append. So write this file starting at the end of whatever's already there is a really useful thing. We'll talk about B and T, the binary and text modes, in just a little bit. So basically, we're going to have to choose when we open access to a file on the computer, whether we want to open it for reading from it or writing to it, or potentially appending to it, adding to something that's already been written. So in my little example here, and I should say, I know Nate and Chris know this. Maybe there's some people out there who haven't been here before. All of the code that we're looking at tonight, or at least all the code that's written ahead of time, is on my website, jeff.glass/electronicsbash. There you'll find a link to this and all the past streams and all of the code, the slides when we have them, although there are none this week, and all of the circuit diagrams when we're doing physical demos. There, I've said that's the preamble. That's the full preamble done. Now we can just do things. So I'm going to use this open function. I'm going to give it a file name. In this case, I've said hello-world.txt. Although this could be, whatever we want it to be. And then I'm going to give it a mode. In this case, I'm going to say write to this file. I'm going to assign the results of this open function to a variable name. Using something like f or file or something like that is pretty common as a convention, just because you're going to be referencing this name quite a bit, so keeping it short is really handy. So f represents a reference to a writable file object. And once I have that reference to that file object, I can say, okay, f.write to yourself some string value. So I can say, write to this file, hello world, and then when I'm done with it, when I'm all said and done, this file is got everything in it that I want to write, I'll call f.close and close off the reference to that file. So if I run this code here, we shouldn't get anything out on the interpreter, and we don't, that's very good. But if I go into my text editor, and I'm just using Genie here, which is one of the built-in text editors that comes with the Raspberry Pi. We're getting a little ahead of ourselves here. Here's some little some snippets of projects coming later. And I load up the hello world.txt file. We'll see it contains exactly what we thought it would, the string that I put in, hello world, exclamation point. If I choose something else, this is something else, and I run this code again, we'll see now my text editor, Genie here, is nice. It says, hey, something more recent is on disk than I know about. Do you want to just reload whatever is most recently stored in this file? And yeah, I do. And it says, hello world, this is something else. You'll notice that we don't have our original hello world text. So if I just say, hello, Chris, and I run this file, we'll see that when I load that file up fresh, we just get hello, Chris. We lose everything we had before, and that's because we're writing to this file in W mode, write mode, which by default writes over anything else that's in the file. If we were to open this file in A mode, append mode, and say, hi, Nate, what do you think is going to be in that text file when I run this code? I'm going to run it. When I open that text file, we should see that we have hello Chris and hello Nate on the same line. When you're writing to files, you have to be explicit about where your new line characters are, because in a way, putting an enter character here, this is a different text file than this is. So if we wanted to output a new line in here that said, say, hello Palmer, and we want that to be on a new line from everything else, I'm going to add a new line manually at the beginning of the string, and the way we represent that in Python is with the /n character. So this is a shortcut for saying, hey, a new line here, please. So when I run this code, and I reload my text, I get my previous text, hello Chris and hello Nate, because we're still in append mode, and then my new string is a new line followed by hello Palmer. Nate asks, will it create a hello world.txt if it doesn't exist? It definitely will, yes. In fact, I can show you that. I'm in this folder here, where I have just the one text file, hello world.txt, and everything else is the Python files we're working with this evening. It might be a little bit small in text size, but I guarantee you it's just the one text file there. Let's change the file name we'll call this create a new file.txt, and we'll say this is a new file. And we'll do that in write mode. And when I run this code, we should see that there's a new text file here called create a new text file. And if I open that up, it says this is a new file. So yes, Nate, by default, it will create a new file with that name if it doesn't exist. We'll get to a little bit later how you can tell in advance whether a file exists or not, as a way of like, if this file already exists, do one thing. If it doesn't already exist, create it. That's a pretty common pattern. I just want to introduce a couple of other things first. Hi, Palmer. Palmer, I didn't know you were lurking. I just took a stab in the dark, but it's nice to see you this evening. I imagine Katie's not with us this evening, but if she is, hi Katie too. Katie will work you into the examples, in spirit or in person. So yeah, this is the gist of writing to files. It's not the most common way you'll see, but I want to introduce this very basic open, write, close syntax here. Hi, Katie. Amazing. So we can write a single line to a file. Here, let's go back to our hello world.txt file here. We could do multiple writes in a loop. We could say for I in range 10, f.write, this is line, and add this string representation of the line, and then maybe put a new line after it. And then we'll close that all out. So when I run that code, we'll see our hello world.txt now just says this is line 0, 1, 2, 3, 4, and so on. Now, of course, of the line, they don't match the line numbers here. But just as a demo, right, you can write to this in a loop and so on, right? That's the easiest way of writing to a file. Before I show you how to read from a file, I actually want to show you the much more common way you'll see of opening a file for reading in Python using the with statement. This is the with .py example that you'll see on the electronics bash, jeff.glass/electronics bash if you're following along at home. We'll get rid of a little bit of this cruft here. This is the core of this example. So rather than saying, assigning the result of this open statement, this writable file object to a variable f, explicitly writing to f using f.write and then calling close, it's much preferred to use, oh, what have I done? Oh, I've closed all the things. Where do I get that view back? Maximize view? There we go. I don't know what I clicked to make that happen, but it wasn't what I wanted to do. In any case, we're going to use this with statement here. So we'll say with open, and just like before, we'll give it a text file's name. In fact, let's just go back to hello world.txt. We'll give it a file name, and we'll give it a mode. So say with open as f. And that's going to, just like before, assign the results of this function, which is a readable, writable file object, and give it a name. That variable is going to be called f. And then within this new block of code represented with the if function, we'll still call the same f.write, and we'll give it some text to write to a file. So if I run this, let me show you, it does exactly the same thing, and then I'll tell you why we might want to do this. Right, so here's some text written in context. It says this is written in context because this with statement is part of what in Python is called a context manager. And the nice thing about this, you'll notice I have an open statement here, but I actually have no close statement. The open statement, using this context manager with the with statement, means that whenever we're done with whatever code is inside that block, we're going to take some specific actions, depending on what we're using as the action that we're using here in the opening part of our block. So in this case, Python knows that sort of the opposite, the closing action of the context manager that is open is close. In Python terms, we would say the entry function is this open statement, and because we're using open, Python knows that the exit statement, the exit command, should be close. So this is automatically closing our file off for us. Actually, I don't think I showed you why close is important. Let me just show you here. So we've got in our text file, this is written in context. If I go back to our original example, open our file, write 10 lines to it, but I don't close it, let's run that code. Go to my text file here. I get nothing. Many operating systems, and certainly Debian that the Raspberry Pi OS is built on, don't successfully write to files unless you explicitly say, here's all of my data, and now I'm done, commit this to disk. Mostly they're filling up some kind of a buffer, and then when you say, okay, I'm done with this file now, do with it what you will, then they will save them. So by getting rid of that f.close statement, I haven't actually written anything to the disk. I've just sort of filled up a buffer that would be dropped to a disk when it was closed. And that's the advantage advantage of using this with statement is that whenever we're done with this block, whenever we come to, say, this print statement here, we are done with the above block, and you can tell we're out of that block, of course, because we're not indented anymore. This will automatically run f.close whenever we exit this block. So just to show you that this works, we'll run this. We'll say we're done with the above block. If I look at my hello world.txt, we can see this is written in context again. This works whether we complete everything in this block successfully or not. So let me show you something here. So this code, right, this writes 10 lines and then closes. If I run it, right, this works still. We get our lines 0 through 9. But let's introduce a little bit of a hiccup here. Let's just create a little bit of delay. I'll say from time, import our favorite function sleep. And after I write out these 10 lines, I'm just going to say sleep for 10 seconds, just to give ourselves a big old window. And when we want that to happen, I'll say preparing to sleep. So what's going to happen here is I'm going to try writing these 10 lines to the file, then I'm going to say, hey, we're done with that, wait 10 seconds, and then close the file. So if I run this, it says preparing to sleep. If I hit my stop button here and cancel the program, right, not running anymore, and I reload this file, just like before, because we didn't get to that close statement, nothing has actually been written here. We didn't get to that close, so nothing's been actually committed to disk. With the with statement, I can say with open, and I can say in there, I can say inside or outside the block, frankly, but inside the block, right? So if I say sleep 10 in here, right? So in theory, if there was an explicit close statement, it would happen just there when the whole block is done. But even if I run this code, oops, got to import my sleep function from time import sleep. Even if I run this code and then I cancel it, if I go to my hello world.txt, I can say, oh, we get our text back. This is written in context. No matter what reason this block exits, whether it's because the code inside of it finishes, whether it's because there's an error in my code, a typo or something like that, whether it's because we hit the stop button or, Control C on your keyboard, that sort of is the keyboard interrupt version of the stop button. No matter what happens in here, whenever this block exits, we're going to run our exit bit of code, which in the case of the open function is the close function. Does that all roughly make sense? How we're using this context manager to sort of guarantee that the sort of setup and tear down of the file object is happening no matter what happens in the code here. This is the reason that we typically use this with open, this context manager statement to work with files, because it guarantees that even if something bad happens in here, or even if that's just an error, let's give ourselves a new text to work with. This is still in context, right? Even if I make a typo, like I call sleep 10, right, and I run this code, it says, oh, sleep is not defined, but this is still in context, still got written to the file, and that file got closed out because we're working within this context manager. Yeah? Questions on that? Comments, issues, concerns? We won't get, that's as deep as we're going to get into context managers. You can actually do more things with them, but this is the context you see them mostly in. Chris asks, why would you do the first version? Most of the time you won't. It's good to know what this syntax is in case you ever need to explicitly close a file, which you might want to do in a situation where you would, if you are within this open block here and you need to say something like if some condition f.close, right? Perhaps you need to close it and then reopen it in a later context. That's one possibility. Mostly this is just to introduce the ideas of opening and closing. But a lot of the times for the kind of stuff that we're going to be doing, which is open a file, read something from it, or write something to it, this is the construction you'll use. Similarly, you might need to explicitly open a file outside of a context manager because you're later going to manage its closing on your own. But 90% of the time, this is the kind of thing that you'll do. Give me 1 sec. I asked for questions and then didn't take the question break. So hang on 1 sec. That's very bubbly. That's gonna be a time. let's see. So this has been reading from, or writing to files. Let's look at how you read from files. Let's see. What was my file hello world? I'll just use that. Didn't take the period because there was actually a question. Please bring the questions on. I just have to remember to also bring the beer on myself. Let's look at how you read from a file. Here, let's just do this from scratch. So we'll say, just like before, we're going to use a context manager to make sure that our file opens and closes cleanly. So we'll say from hello world dot, with open hello world.text, and this time my mode will be mode R for read, as f. I mean, this can be any variable name you want. I like to sort of, help myself remember whether I'm reading from or writing to by using, remember to mute that time, infile and outfile as my variable names. These aren't anything special, these are just sort of names of this variable. And I will say, so once you have opened a file for reading with a variable name, you can treat it essentially like a Python list. You can iterate over it like you would anything else with a for loop. So I can say for line in infile print line. So let's see, this is going to be a file read demo.py. So let's put something a little bit more interesting into our hello world.txt file. Let's go back to our first example here where we put 10 lines into it. We'll run that code, right? And we'll just verify this is line 0, 1, 2, 3, 4, and so on. And now when I open this to read it, I should see here, so I have the 10 lines in my program, but you notice there's an additional line break in between them. So I get line 0, which in the text file has a new line character after, has a new line, but the print statement also by default adds a new line after anything you print. So I have line 0, line 1, extra line 2, extra line 3, extra line, and so on. There's a couple of ways we can work around this if this is not what you want. Sometimes this is just nice and easy to see what the different lines are, but often you want to sort of print it out exactly or work with it exactly as it is in the file. So there's a couple things we could do here. One is we could say, hey, print statement, don't automatically put a new line at the end of whatever you're printing, just sort of cap it that way. The way we do that is to say give the end parameter of the print statement as an explicit value. By default, the end value is new line, but we'll just say, hey, end value is nothing. Don't put anything additional onto this line. When I do that, I get just exactly what is in the text file and nothing else. The other thing we could do is strip out all of the new line characters from that line of the file. So I can say, we're going to print line.strip new lines. Right, and this is going to remove any new line characters from the beginning or the end of each of those lines. We see the result is the same. And so really the question is here what you want to do with these lines once they're in your code. For example, a pretty common thing to do would be to say my list of lines is an empty list, and for line in infile, I want to my list of lines dot append line, right? So I'm going to basically go through my entire file, and every new line I'm going to add it to my Python list, and then I could do something internally with it. Now, do I want these lines internally to have a new line character at the end of them or not? If I do, then I might want to say, these lines as they come in from the file have a new line character. So if I want them to be verbatim that, I might leave this alone. Otherwise, I might say line.strip /n, just to take that new line character off the end. But that's just sort of a matter of preference in what you're actually doing with your code. End equals nothing. And there we go. Cool. So reading from lines in a file like this is just exactly the same as as reading from any other list. And once it's pretty common. This is what I do in a lot of my code. Is like you read the lines in a file and you add them to a list in your program so you can do things with them. So I could say once I have that list, I could say print my list of lines element 4. Right. Element 4 is line 4. Brilliant. I could print lines 4 through 7. Let's print a little spacer in between there so we can see when we're starting our sort of bespoke print statements. right? So now I can sort of slice, I can take a slice of this list that we talked about before. This is going to be elements 4, 5, and 6. We don't include this element 7, as you recall. So this is the first element of the list to include. This is the last element of the list to not include. So I can say, what are lines 4 through 6? Lines 4, line 5, line 6, and so on. This is a pretty common construction, right, is to iterate over all the lines in your file, and maybe not even necessarily print them out, but just add them to a list so you can work with them. Let me show you another example of things you might do with that. A slightly more complicated example, making use of another fun library called itertools. Itertools is like interesting tools for things you might iterate over. It has this neat function called permutations that allows you to generate all of the permutations of a given string or set of objects or various other things. So what I'm going to do is write out some permutations to a file and then read them back in and sort of just use this as one more example of how to read and write basic text from files in Python. So I'm going to bring in my permutations function. I'm going to start a new file name, call it perm.txt. And what I'll do here is I will create a list of numbers that is, in this case, 5 digits long. So data is range 5. So that's 0, 1, 2, 3, 4. And I'm going to write it to a file and then read it right back in. So I'll say with open file name, so with open perm.txt in write mode as my output file. And this is why I like to use these infile and outfile sort of monikers, is because it helps ground me like, where's the part where it's writing to the, oh, it's outfile. Okay, so I must be writing to the file here. Oh, it's infile, I must be reading from the file down here. So I'll say for p in all the permutations of my data of length, how many, right? I could do my permutations of length 3, of 4, of 5, and so on. I'm just saying, give me all the permutations of length 5. Write each of those permutations to the file, followed by a new line. Here, we'll run this, and then we'll look at what that file actually looks like. So I will say from sys import exit, and we'll just end our program early here. We'll just say exit, right? So we'll run that code. Nothing should be on the command line, and when I open our new file perm.txt, I get all the permutations of the digits 0 through 4, right? So starting with 0, 1, 2, 3, 4, 0, 1, 2, 4, 3, 0, 1, 3, 2, 4, and so on. That's just what this built-in permutations function of the itertools library does. It generates all of those. And now we will bring them back in using our read statement. So I can say with open our same file name, so perm.txt, in read mode, refer to that as infile. And then for each line in my infile, I'm just going to print that line to the screen, and I'm going to use this end equals, nothing quotation. So I'm not going to put an additional new line character on there. I'm just going to, print out whatever's on that line, which will itself contain a new line character. So if I run this, I should see basically what exactly was in that file, starting with 0, 1, 2, 3, 4, 1, 3, 4, 2, and so on up to 4, 3, 2, 1, 0, and so on. Yeah? So this is all well and good, but in a way we've lost a little bit of data doing this, and here's why. When we generated our permutations up here, though I didn't call this out at the time, here, I think I can show you. Print p.type, I think that's the right construction, and then I will just exit here. So all this is going to do is print the type of this first permutation, and then I'm going to quit. So I'm only going to do this once. Well, this is not what I intended to do, but it's going to give us our answer anyway. This says tuple object has no attribute type. Let's see. Oh, am I thinking of the type function? I might be. Type of p. Run that. Yeah, that's what I want. So these objects are being generated as tuples. And tuples, you remember, are a lot like lists in Python. You just can't change them after they're made, right? So as we see in our text file, they're defined with sort of, instead of square brackets with normal parentheses, and this is the normal form of a tuple that we've seen before, sort of a list of numbers separated by commas, could be a list of strings or objects, and so on. So we generated these tuples, and then to write them out to a file, I had to make them into strings, right? Because strings are text, and we can only really write text to files, at least in this case, right? So I said, give me the string representation of that tuple, and write that out to a file followed by a new line. So when we bring them back in, we're not really bringing them back in as tuples, we're bringing them back in as strings. So down here, let's just say print type of my first line. And here, I'll tell you what let's do. Let's do this in one print statement. So for each line that we bring in, I'm going to print its type plus a space plus the line, or as a colon, plus the line itself. Just to reemphasize the point, oops, type line. Here we go. Probably have to cast this to a string so we can actually display it. And we'll see that each of these lines of the file, of course, is coming in just as a string of text, right? It's not really coming in as a tuple. It's coming in as an open parenthesis, a 0, a comma, a space, the digit 1, a comma, a space, a digit 2, and so on, right? Does that sort of distinction make sense, right? How these are not coming in as sort of data, but as the text representations of the data that we've stored to the file, if that makes any sense? So writing text to files is all well and good for actual text, strings, names, bits of plays, dialogue, user data, addresses even most of the time. But for structured data like, a tuple or a structured list of things or a dictionary, this is not actually necessarily the best way to store this data. Let me see if this is scrambled demo. Nah, it's essentially the same thing. Let me show you a slightly different way to save data to a permanent file that's a little less human readable, but allows us to, sort of restore this data automatically so we can use it. I really want to make sure I'm sort of illustrating the difference of what's happening here, that we're not bringing our sort of tuple objects back in as is. We're bringing them back in as text. So here, maybe here's a way we can illustrate it. For each of these permutations, I'm going to print, let's start a count. Let's say count equals 0. And as we go through our permutations, I'm going to say print the count. And we'll increment that count by 1 each time. This is just going to give us an indication of what we're looking at here. And I will say, so lines, permutation, say number 1, and the first, let's see, how are we going to illustrate this? Let's do P0, 1. So we'll get the first 2 elements of that permutation. So when so I, of course, have to concatenate that to a string. So now let's run that with a little bit of format cleanup. And we'll just see, so all I'm doing here is printing the first element. Let's print the first 2 elements. That'll make it a little clearer, of each of the permutations as we go. So the first permutation that we generate has first elements 0 and 1, 0 and 1, 0 and 1, and so on. Then we get to some 0 and 2s. So this would be like 0, 1, 2, 3, 4, 0, 1, 2, 4, 3, and so on. I'm just giving the first little slice of it because I'm going to illustrate how these 2 data structures are different. Right, so I'm taking the first 2 elements of my list of 5 numbers. In fact, let's print out, this will be even clearer, because clarity is good. So we're going to print out the whole permutation followed by just the first 2 elements of the permutation, right? So here's the whole permutation, and here's the first 2 elements, 0 and 1, and it's 0, 1 for a lot of these. Then we exhaust that, we go to 0, 2, 1, 3, 4, its first 2 elements are 0 and 2. Sort of makes sense what we're looking at here, right? Now let me show you what happens if I do exactly the same construction with the lines that we're reading in from the file. So here I'm going to need to reestablish my count variable, start my count back to 0, and we'll increment it each line just so we can see a little bit of difference in them. So now I'm going to print the count, I'm going to print each line, and I'm going to print the first 2 elements of each line. And we'll see that unlike, so a couple of things have happened here. Unlike the example above where we were getting individual slices, individual members of these tuples, the line is coming in as text. So here, let's go up to our 0th line here. This is just a string, an open parenthesis, a 0, a comma, a space, a digit 1, and so on. So its first 2 elements are open parenthesis and 0, right? The first two elements of, say, this string down here are open parenthesis and 1, because this is just a string of digits. Python doesn't know yet that it represents a tuple. It just read in some digits and some spaces and some parentheses, and we'll have to deal with it later, all right? Is this sort of making sense? How the difference, we're generating some numbers, we have to sort of treat them just as basic text and characters to get them into a file, and so when they come back from the file, you know, they are just text until we tell Python otherwise. Yeah? I think? All right. Well, assuming that makes sense, as I alluded to just a minute ago, let me show you a slightly better way to get structured data in and out of Python. So this will be the first pickle example that we work with this evening. I have to say, people who write Python libraries, especially some of these like more general original ones, have a real flair for like integrating py and pickle and Python and various things into their adorable names. And so the library which takes some features of your program and preserves them is called the pickle library. In fact, there's an offshoot. So Chris, you beat me to it. Yes. So the pickle library is fairly versatile, but it's very commonly used. It has a couple of very specific limitations that are there on purpose to sort of keep its functionality core. There are some extended versions of pickle that make it more safe to use in a context where you don't necessarily trust the code you're running, but because of that, they impose some additional limitations, and one of those varieties is literally called dill. In fact, if we go to our package manager and we search dill, we'll see if this comes up here. There we go, dill, for serializing things that are not things. So yes, no, that is literally a thing, Chris. There's some other good, Gherkin, I think, is another one that has some slightly different functionality. Yeah, Python library writers having a good old time. So the pickle library is almost certainly pre-installed in your installation of Thani. If it's not, it might be part of the standard library. Let's see if that's true. Yeah, it's in lib.pickles.py, so that must be in the standard library. So don't worry about installing it. It comes with for free. We'll just import the whole of the pickle module in, and let me show you how it works. So let's say we have some structured data. In this case, a dictionary of what colors that fruits are. Not a particularly versatile program. But let's say that my dictionary says that apples specifically can be either red or green. So the key in our dictionary that is apple references this list, which is a list of 2 items, red, green. Banana, it has the value yellow, and the key carrot has the value orange, right? To make this just a little bit more visible what's happening each time I run this code, added a line using our input statement here, which I don't think we've talked about the input statement since like week 2 of Python chat. So if you've forgotten, the input function, you give it a string, which is basically a question to ask the user in the console down here. And whatever they input, sorry, clear that out, will be returned to you and assigned to a variable of your choice. So in this case, I'm just saying, let the plum key in my dictionary reference whatever the user puts in. And then I'm going to write that information out to a file like so. So just like before, I'm going to use a context manager to open and close my file to make sure that it's opening and closing cleanly. I'm going to say open. I've chosen the name fruits.p. There isn't really a standard file like extension name for pickle files. I have sometimes done this as like file names that have relevance to the kind of information that I'm saving. But .p will do for now. I'm going to write to it in a binary format. So specifically, rather than saying just W, I'm going to say I'm writing binary data. So Python's going to be generating some 1s and 0s that represent my data. I just need to store them into a file that I'll call outfile. And then instead of doing .write, I'll say pickle library, please dump some data into that file. The data that I want you to dump is my fruitColors library, dictionary, I should say. And the file to put it out to is our output file here that we have. Yeah? So I run this code. It's, of course, going to first ask me what color is a plum. I'll say it is purple, and my program completes. So if I try and go and open fruits.p in my text editor here, there it is, fruits.p, I'm going to get an error. I don't know, you probably can't see it down here, but it says, let me scroll down to that error a little more. Fruits.p does not look like a text file, or file encoding is not supported, right? Because we didn't write to this as text. We just said, hey, this is going to be some binary ones and zeros, right? So going to have a hard time reading that into a text editor. But with the opposite of pickle.dump, using pickle.load, and again, this structure should now start to look very familiar, with open, fruits.p, read binary data, so mode RB as infile. I'm going to set my variable name equals pickle.load, load that infile. So this should be creating a new dictionary and assigning it to my variable here, fruit data, and then I'll print that right out to the screen. So if I run this code, I should get back my original dictionary down here. So apples can be red or green, bananas are yellow, carrots are orange, and plums, you'll see over here, are purple. If I choose a different descriptor for what color plums are, I'll say plums are sort of a purplish reddish color. Right? Now when I run my load program, we can see that my plums are sort of a purplish reddish color. Because of course this file is being updated each time that I add into my information here. So pickling is a good way to store structured data. If you have all your data in a list, in a dictionary, and so on, rather than storing it to a flat text file, storing it to a pickle format can be a way to preserve that structure in a way that's really easy to load back into your program. Yeah, makes sense so far? Right? So text files for writing text-like things, pickle for writing object-like things. And when I say object-like things, we can do things that aren't just sort of basic data structures. We can actually do whole objects. So I could call back to our GPIO0 library that we've worked with a couple times to turn on and off LEDs. I could say red LED equals LED 21, green LED equals LED 20. Let's see, my LEDs is a list of LEDs consisting of red LED and green LED. I'm actually not 100% sure this is going to work, and if it doesn't, we'll learn something together. We'll call this pickled LEDs. There's almost something there that's pick LEDs, but I think that's just a little bit too much. We'll call this pickle leds.py, and I will say with open with open leds.p, say, write binary data to it as outfile, pickle.dump, my LEDs outfile. Right, if I run this, helps if I bring the pickle library in, import pickle, run that. Okay, good. This did fail, and I'm glad it did. So I'm getting this error, can't pickle weak ref objects. So this is a place where we run into some of the limitations of the pickle library. Actually, I wonder if dill will pickle this. Let's find out, because dill will typically pickle things that pickle can't. I haven't installed dill. Let me give this a little try, and if it doesn't work, either way, I will explain what is actually going on here. We'll just install our dill library quickly. So one of the things I love about doing these classes is, like, I don't know, I learn things along with y'all. Process failed, certificate failed. Aw. All right, well, we're not installing dill today then. The gist of it is, Chris says plant and harvest dill. Yeah. There's also, I believe, a time THYME library, unrelated. The issue with what's happening here in this error that we're seeing, cannot pickle weak ref objects. And you might see a variety of errors related to this, cannot pickle this, cannot pickle that. Let's see, what other libraries have we used recently? That would be interesting. Here, maybe we'll make our own class that will illustrate this. So we'll say def LED, def init, self and number, self dot number equals number. The world's least useful class. So we'll just define our own LED class in here for the moment, and we'll see, oh, right, not def class LED, it extends nothing. That needs a colon. There we go. So that code ran successfully. Of course, these are no longer our GPIO0 objects. This is this little dummy class that I have written here for the sake of illustration. So why can I pickle this class, right? Why can I pickle this class that really has no particular use to it, but I could not pickle from GPIO0 import LED? Why was this not pickleable? And the secret is that behind the scenes, the pickle library is not storing an entire copy of all of the data and the functions related to your class and its attributes and its functions. It's actually just storing a reference to the names of those things. So this is not really saying, hey, I know exactly what a red LED is and what an LED is and what it means in GPIO0. This is just saying, hey, I have a list of objects called redLed1 and greenLed. RedLed is what you get when you initialize LED with this parameter, but it's not actually going to go out and do those things. It's just sort of creating a list of the names and attributes you would need to recreate that object. And there are some times where the pickle library cannot guarantee that that will be enough information to recreate the object that you are trying to save. And that's what this weak ref refers to, is it's saying, hey, there's some information here about, like, you know, when I use this LED, say 21 function here, the Python code is doing a lot of stuff under the hood to say, like, okay, reach out to the part of the CPU that controls LEDs and check on its state and check on its conditions, all this stuff. And the pickle library says, hey, that's beyond my scope. I just want to create an LED object with this number. So if we're sort of weakly referencing the things that are outside of our scope, we cannot pickle it directly. So if you run into this, start thinking about ways, perhaps if this was our code and I wanted to save our state, maybe I would instead want to, create a dictionary that was the colors of my LEDs and the pins that they were assigned to, and pickle that. And then when I reloaded this information from file, I could use that information to regenerate my objects or something like that. So you start thinking about different ways to strategize around different ways of pickle not being able to serialize anything that's sort of weakly referenced. I know that's kind of a hand-wavy explanation of what's going on in there. I don't suppose we're not gonna go super deep into what pickle is doing, but just know that for fundamental data structures like dictionaries, lists, tuples, and lots of fundamental classes, you can just save them out to a file as a pickleable object. If you run into failures, this is why, essentially. Questions? Just for the nerds in the room, are there any nerds out there? Are there any nerds? Are there any nerds in the crowd tonight? I think I see a couple of hands up in the back. Yeah. Okay. So for the nerds out there, let me just give you just a little brief aside into the other way that you might Shield's face, other ways that you might solve this issue. Going back to, I didn't prepare this demo beforehand, so I'm going to wait a second while VS Code opens for me here. But in, let's see, pickle. I may not be in the right branch of my code to make this work. But let's see here. Showmaker QList, plain controls. Sorry, I'll only find this because I think it will be interesting. I hope it's interesting. Plain controls, serial controller. Oh, this might not be the most recent. Oh yeah, I'm in the wrong branch of my code to show you this. I'm sorry. But I can show you on GitHub, I bet. Unless I didn't push my code. I'm so sorry. I have become a total Git and GitHub convert in the past few months of working on all this stuff distributedly. But I'm also not great about remembering what branch I'm on and where. Let's see. Plain controls. Serial plain controller. I might be in the wrong branch here too. I am. Sorry. QList overhaul, I bet, is where it is. plain controls. No, it's not here either. Well, what gives? All right, I'm gonna try one more thing, and then I will, you know, come back to the actual thing. Let's see. Is it lighting controller? Lighting control. Plain controls. What I really I'll tell you what I'm looking for. There are basically ways to when you call the pickle or unpickle something, you are actually calling specific functions of your object, which usually are just like show me the basic state of the thing. Oh, here we go. Yes, this is what I was looking for this whole darn time. I think. Nope. I was wrong too. Basically, you can override those built-in functions, and basically say, hey, when you try and pickle this thing, instead of just sort of giving you a naive representation of the object, here's some specific instructions for how I want to be pickled, because some of the things that I contain are not going to be sort of natively pickleable. But I think I've actually taken that code out of here because I'm no longer using the non-pickleable parts of my code, which is great, but it means that this example that I've now wasted like 3 minutes digging around in GitHub to show you is... Oh, here we go. Yes. Here's what it is. So, sorry, nerds in the crowd, just for those who are curious, when you call something like pickle.dump on an object, what's actually happening under the hood is pickle is by default saying, okay, does this object have a get state function? It's a dunder get state function. Those are those functions with those double underscores that we talked about before that mean special things to Python. If it doesn't, it sort of falls back to a very basic way of understanding what this object is. Is it a list? Is it a dictionary? And so on. But what you can do, you can also write your own version of the get state function for situations where your object is not going to be natively pickleable. So in this case, in this other application that I'm working with, I've written my own get state function that needs to basically return a dictionary that contains all the information about my object. But I had some parts of this object, in this case my relay controller that was interfacing with an external USB-controlled relay board, that weren't pickleable. Things like multi-threading objects. And this is something we run into quite a bit, is those threads aren't necessarily guaranteed to be in a particular state when you save them. So Pickle says, I don't know how to preserve the state of this, because when it comes back, like, I don't know what state it's in now. How am I know that I'm going to be able to faithfully recreate it? I'm going to fail. So what I say is, okay, when I'm saving the state of this relay controller, my thread that I'm using to blink some relays on and off, that's not going to actually reference a thread object. That's just going to reference nothing. And same for this external C library that I'm using to actually control the USB functionality of this board. That's, again, like, Python can't really save this internal state of a C library, a .dll file in Windows. So again, that's just going to reference nothing, right? But then it's up to me, when I reload this library, when I unpickle this, when I pickle.load this object, I have to say, okay, when that comes back in, I'm going to need to repopulate that thread and that DLL, that C library itself. And I have an external function to do this that says load lib and init. So I've overwritten my get state and set state object so that this object, which normally when I tried to pickle it would break, now when I pickle it, it says, okay, well, the pickleable parts are fine, but please don't try and pickle that thread and that external C file. And when I load you back in, load all the state you know about, and then I will take care of writing the code that generates that state itself. Sorry, for the rest of you out there in the crowd, I know that may have been a little bit technical, but for the nerds in the back there, especially you sir with the beard, and you ma'am in the shirt, that's for you. Enjoy that. So that's pickle in a nutshell. Create some objects, pickle.dump them out to a file, pickle.load them back into your program. There's one more data type of writing to files that I want to look at, and then I want to look at a couple of common patterns to working with and writing files that we have not touched on yet. So that is JSON. And we've talked about JSON before back in our class about working with web APIs and dealing with web data. JSON, for those who We're not here for that class. We need a refresher. So it's funny. JSON is kind of a slightly esoteric topic if you're coming from other programming languages, but it's really nice that in Python, JSON essentially mirrors the internal structure of a dictionary, which we know all about. I've also heard I say JSON, some people say JSON. I don't know. I don't know which one is technically correct. I'm going to continue to say JSON because then it's definitely not JSON. Man, there's got to be some reference to the Argonauts. That's a real missed opportunity there. All right, author of the Argonauts. We'll get there. So JSON, you remember, basically a JSON object is just a dictionary in Python, right? So some key value pairs, and those values could be strings, could be other data types, or they might, in JSON, they might be lists, right? So JSON data by its definition has strings, is a dictionary of strings or maybe some numbers and lists. That's all it is. And you can nest these things within each other. So here's some sample JSON data that I'm going to try and save to a file and bring back. So my data equals some key value pairs. The title of my data is just data. It's of type dummy information. The content key refers to another smaller dictionary, which says that the quality is good, which is questionable. The compression is poor, that's for sure. And my data points are 3, 1, 4, 1, 5, 9 as a list, and so on. And then the author in this case is the Argonauts, because that's it can't pass that by, right? So this is the general structure of JSON data. It's just a dictionary, sometimes a dictionary within a dictionary, or nested within that. You can also use lists. That's all that JSON is, right? If I want to write this out to a file, I'm again going to use our context manager here. Say with open, in this case, I'm going to say data.json. There's no reason this has to be .json. I just like to say that it's .json because that makes it clear what kind of data the user can expect to read from it. And I'm just going to write to this like it was a regular old text file. So I'll open that as my name outfile, and I will dump my data variable here, say json.dump data to my outfile, right? So if I run this code, no errors there. If I come over to our text editor and I open up data.json, I get what is essentially a text file, but it's got all this, it's structured in exactly the right way, right? So I can see all my formatting here, title, data, type, dummy information, content, and so on. And what's nice about having it formatted in this way is that this is still relatively human readable, right? We can go through and say, okay, title is data, type is dummy. It's not sort of hidden behind an unknown binary format like these pickleable objects, but it's still really easy for a program like our JSON loading program, if you're following along at home, to read that data back in as structured data. And it looks just like you might expect from our pickle example. We'll open our file in read mode, and we'll say our variable equals json.load from our file, and then we'll print it to the screen. So when I run that, I just get my original JSON library back, or dictionary back. So title is data, type is dummy. And to show you that this is not just text, that this actually is a JSON file, let me get you just the title from my data. My title was data. Let me get you just the content from my data. Remember the content is a reference to this smaller dictionary, which is quality good, compression poor. Let's get just the data points out of that dictionary. So we'll get data with the key content with the key data points, and we get our list 3, 1, 4, 1, 5, 9, and let's get the last element of that list is element 9, right? So rather than it looks like text in a file, but because it's formatted in just the right way by our JSON library, it makes it really easy for Python to bring that information back in. And that's kind of why JSON has become really popular as a format for passing configuration data or program data. It's a human readable format that's still consistent enough that it's easy to pass this data back and forth. You might remember that when we were working in the, interacting with the YouTube API a few classes ago, all that data was coming back as JSON data, because it's really nice for me to be able to say, or just to see that in my request, I'm looking for the title of this video, and I'm getting that back in the response. But I also want my program to be able to sort of parse out the title of my video or its runtime or its number of views in a really programmatic way and work with that data. And JSON is just, it's a nice middle ground between human readable data types and sort of machine processable data types. The JSON library also, so as we As we can see here, let me go back to just printing out the whole contents of my dictionary. This is all well and good and pretty human readable, but in the terminal here, it's a little bit hard to parse visually. Not in the machine side. The machine's doing fine. It's just a little bit hard for me to read, especially with this wrapping. So the pprint, the pretty print library, which I think we looked at in the web class as well, can be really useful for printing this out in a slightly more readable fashion. We'll create a pretty printer object and tell it how much we want to indent each of the successful levels. And then rather than calling print, we'll say printer.prettyprint or pprint. And that's going to give us this printout, which is sort of nicely indented, making it a little bit easier to read what the contents of the JSON are. And that's really nice. This is only, not that big of a JSON file ultimately, but we can imagine if this was, a bunch of data coming back from an API as data about some map or something. This could be hundreds of lines long, and so the ability to just visualize it nicely on our screen is really helpful. So the pretty print library, the pprint library, is really useful for that. Yeah? Questions? I feel like we're moving kind of fast, but also these are sort of, like I sort of said at the beginning, it's not like it's a super svelte, flashy demo. These are just kind of core functionalities that I think everyone should know about, because now we have the ability to not only generate data, but save it to a file, so we don't have to regenerate it the next time. You might remember from our interacting with the web class that I actually overran the limits of how much I was allowed to access the YouTube API, even though the information I was getting was not changing every time I ran it. I would, reach out for data and then do some processing on it and print the results and then throw that data away. And then I would reach out, the next time I was like, oh, that's interesting, I'll change my code a little bit, reach out to YouTube for the data, get the data, do some processing, throw the results away. What I really should have been doing is reaching out to YouTube for the data, getting the data, storing the data, and then doing all of my experiments on the data locally rather than asking the web for it every single time. So that's something that I would encourage you to do. If you're doing anything that generates a bunch of data that's going to be relatively consistent, and then you're going to sort of, if the part that you're trying to work out the code for is the messing with that data, generate the data once, save it to a file. Maybe that's a text file, maybe that's JSON, maybe it's a pickled object, right? If you're generating a big sort of nested list of, maybe it's a multi-dimensional array of some kind, just pickle that object out to a file and then load it back in the next time. Can really save in a lot of computation time or web resources or what have you. Let me show you an example of that, actually. We sort of previewed this a little bit before. I'm going to load up, this is the Henry 5 example from Electronics Bash if you are playing along at home. Here, stand by 1 second. So this is going to throw back a little bit to some of those web access classes. What I'm going to do here is download the full text of Henry V from MIT, and then I'm going to strip out all of the lines that are the actual text and none of the additional formatting. So let me show you what I mean. Let's see here. I think I have closed this tab, / Shakespeare. Let's see, this is Hamlet. What I want is Henry V. So this is the, let's see, entire play in one page. So this is the page that I'm going to be getting all of the information from. Oh, for a muse of fire that would ascend the brightest heaven of invention, and so on and so on and so on for thousands of lines, right? Now, of course, as you remember from our web demo class, right, this is not, when I make a request to this web page for this information, I'm not just going to get the text from the web page, I'm going to get a whole bunch of additional information about formatting and header sizes, and then, in the case of this page, the actual text is all sandwiched between these various name tags, which tell us which line and which scene we're actually looking at, which is kind of a cool bit of formatting, actually. This would allow us to do some neat programmatic stuff. So what I'd like to do is, is download all of this and then work through it and sort of isolate the individual lines that are the text, but throw away lines like href equals / Shakespeare homepage, things like that. So let's look at a way we might do that. So what I would like to do here is, so my URL of that page we were just looking at is as follows, shakespeare.mit.edu, and so on and so on, right? We'll come back to why I've defined these additional functions here. we're going to use the requests library that most of you will recall to get the contents of that web page. I'm going to say requests.get my URL that I defined up here, and I just want the text from that result. The get method, you recall, on its own, we not only gives us the text of the web page, but things like, you know, the status of the response. Is it a 200 response because it was good? Is it a 404, that error message that we always see? I just want to get the text of that response. And what I really would like to do, come to think of it, is save this response to a file. So I'm going to say with open henryraw.txt for writing as outfile. Let's see, outfile.write website text. I'm not 100% sure it's going to do what I want, but I'm going to try from sys import exit, right? So what I'm going to do here is basically say get all the text from that website and just write it out to a local text file for me. And I'm going to exit the code there. Let's see if we get an error. It's an awfully big file to write, so it's possible this will fail. No, that seems to have worked all right. So we've run through that code. Let's just see what that file now contains. henryraw.txt. There we go. So this is the view source version of the website. Doc type, public, and so on and so on. That's great. So what I'm going to do now is, rather than operating on this, instead of pulling down the information from the website every single time that this code runs, I'm going to make use of an additional functionality that I think I've actually built into another example here from the OS library. I'm going to say from OS import path. The OS library, which we've stumbled upon a couple of times before, has lots of useful functionality that sort of like abstracts away the idea of an operating system, right? So, you know, on Raspberry Pi, our files look like they're under the, you know, the /home/pi directory, but on Windows we might have the C drive, and on Mac you have sort of a different, slightly more Unix-y concept of where files are. In this case, using the os.path function, let's just say I don't really care if I'm on Windows or Mac or Linux or something else. I just want to tell you sort of like where relative to the current folder a file is, and you tell me that that's okay. That's really all I want. So let me comment out a couple things we're not using yet. We'll say that, and we will say, let's move this around down here, and boop. Let's just clean this up for this example a little bit here. So what I'm going to say is, if path.exists, let's make our file name into a variable. File name equals, what do we call this? henryraw.txt. If path.exists, henryraw.txt. If not path.exists, henryraw.txt, then I will say, we'll do this. Right, so every time I run my code now, it's going to say, hey, does the raw text of Henry V exist on my computer already? If not, go out to the web and download it. But if it's already there, we might as well make use of it there. So I will say, let's see, with open henryraw.txt, with open, I guess, file name. Let's see, let's make this into a variable. Let's say file name equals henryraw.txt. And then we don't have to keep retyping henryraw.txt, which just feels a little bit gross somehow. I'm not entirely sure why. But I don't know, maybe that's just me. With open file name read as infile, raw text equals, let's see, how do I want to bring this in? I want to bring this in as one large file icon, as one large file for, let's see, so we'll say raw text equals the empty string, and I'll say for a line in infile, raw text.append line. I think that's going to be fine, and we'll exit there. Let's just double check that that actually works. String, I was just going to attribute append. Raw text equals, let's see, plus equals line, right? So I can't append to a string. I have to use our plus symbol here. There we go. So then if I print this raw text variable to the end of at the end of our execution, yes, it contains everything that we just had. So what's happening here is if this file doesn't exist on my system, right, and this path that exists is just saying, hey, if by default this is going to look in the current folder where the script is being run. So it says, hey, is there a file called henryraw.txt in my current file? If not, then run the following code. Go to this website, get the text, and write it out to a text file. But if it's already there, we don't need to go out and get it, right? So we can just move on to the next block of code. And that's just going to regenerate our full text of Henry V into a variable we can work with. We'll just say, open that file up, and for every line, append it to this string. So now I have this giant bit of text that's representing all the text of Henry V. And now we can do all of our local processing on it. What exactly is happening here is, is sort of outside of the bounds of our example. This is a lesson on writing to file, not necessarily how to use Beautiful Soup. If you're interested in how to use Beautiful Soup, I encourage you to go back and look at the lesson on working with websites and various things. But basically all I'm doing here is going through using Beautiful Soup to parse this information we've downloaded from the website and identify any lines that have that a name construction that we saw. That was how the code of this website is identifying an actual line of text and not something like, the color or the fact that it's a play and so on. So the takeaway from this example is something like, if not path.exists file name, right? If we don't have a file containing our data, then go to the web, go to a local calculation or whatever and generate it. But otherwise, just pick up from where we left off. Another good example of this is, let's see here, file exists with, where was my last example here? Pickled LEDs. Maybe I saved it in the wrong place? I was messing around in various places here. What is it's called more primes, but it doesn't seem to be here. Maybe it's in my Python programs? Maybe not. Did I write it on the wrong computer? I mean, listen, it's been a week, but I feel like I'm in general putting things on the right machine. Let's see. This is the most recent one. Henry find.text data, JSON, LEDs, pickled LEDs, fruits, permutations, scrambled tuples with file exists, pickle.dump, scrambled read. Create a new file? No, that's not what we were looking for. How very strange. Did I not save it? Maybe we'll try and rewrite this example live, and that will be a good example of like how we're working with these structures. So this is the problem set that I'm going to give us, and it'll be a good example of how to. Oh, maybe I do know where this example is. Is it in with? No. Is it in scrambled read? No. All right. No, we're just gonna have to. Well, as they say, we'll have to do it live. Here's our problem statement. I'm going to write a program that generates a bunch of prime numbers. And every time I run this program, I want to give it a number and say, please generate for me the next 100 primes, 1,000 primes, 10,000 primes, or what have you. I want this to have a list of primes in a file, and when the code sort of picks up from where it left off, I want it to generate the next X number of primes, whatever I give it. Then I'm going to use these primes to, I don't know, do cryptography or some other complicated thing. Anyway, I need to generate a list of primes, and I want to store them in a file, because once I've generated them once, I really don't want to go back. And the primes are always going to be the primes, so I'm not going to generate them again. But for some reason, I really want to generate them myself. A slightly contrived example, but aren't they all? So first, we're going to need a function to determine whether a number is prime. And we'll say that number is num. And I will say, this is going to be a really lazy test for the primality of a number. I will say for d in range 2, int num divided by 2. So from 2 up to half the number, if num divided by d dot is integer, and is integer is a function that says like, hey, is something an integer? We'll call this the more primes program. Return false. Otherwise, for all those are false, return true. So let's just make sure that this works. We'll say for I in range 100, if is prime I, print I. Let's see, is that running? So this should be, could not convert string to float. Oh, that's an error in Thonny. I have to restart Thonny in a second here. But let's just see. So this should be a list of all the primes. I guess 0 and 1 shouldn't be in here, so we really should be starting at 2. Oh, Thonny's crashing hard. Let's just... save. Very good. Close our text editor here, too. All right, come on, Thonny. Come on back. I think I've also opened my Chromium. Yes, we'll close Chromium. Let's just run this one more time. So we'll see. Yeah, so here's all the primes from... Oops, but four snuck in there. That's a bad sign. Let's see. So 4 snuck in there because we're going from 2 up to half the number. This is range 2 to 2, right? Not inclusive, right? So that was not testing 4 successfully. So we should have 2, 3, 5, 7, 11, 13. Let me be clear. As a math minor, this is a very bad way to test for prime numbers efficiently, but it's going to do for our purposes today. In fact, the fact that it is so poor is going to make us all the more motivated to stash our results in a file rather than trying to regenerate them every time we run our program. So I'm going to say, make a new function called def make more primes. And I'm going to give it a new variable called how many. And let's see here. So to generate primes, I'm going to say count equals 0, while count is less than how many. And in this place, I'm going to generate, how many, generate new prime, and increase the count by 1. Right? So that's not actually code, right? That's just a bit of pseudocode, a bit of a comment to remember what I'm going to do in each of these steps, right? And really, I would like to not start sort of at the beginning. I'd like to sort of start with a file if I've got one. A file of existing primes. So let's make our file name something like, let's see, file name equals, let's say, primes.txt. And I will say if path.exists file name, right? So if I have a primes.txt file already, I will say, let's see, I'd love to get the last prime number in this file. Let's say each of the primes is going to be on its own line. So I'm going to say for line in, let's see, if the file exists, I'm going to open it up with open file name read as infile. For line in infile. And really what I want to do is nothing here, but I will say value equals line. So when we're going to loop through this file setting line equal to each of the lines in this file. I'm not going to do anything to them, but when we're all said and done, this line variable is going to hold the last line of my file. I really just want to get the last line there, and I'll say that'll be the integer value of the last line of my file, and I actually want to strip off any new line characters there that it might contain. Let's see. Otherwise, my value is going to be the prime number 2. Right? So let's see here. So if the file exists, I'm going to open it up, get the last value of it. Otherwise, I'm going to start with the prime number 2. So now I would actually do the business of adding new primes to this file. And I'm going to say, let's see, I probably want to start with value plus 1 in each of these cases, and this wants to start as 2. So let's see here. If is prime value, here's the thing we can do with context managers. I will say with open file name in append mode. And append mode, this kind of goes back to your question earlier, Nate. If we open a file in append mode, it will create that file even if it doesn't already exist. So both write and append will default to creating that file if it's not already there. So we'll open that file for append node as outfile. If the number we're looking at is prime, outfile.write string value plus a new line. Actually, probably wants to be, oh no, that's probably okay. And if that's true, then I want to update my count of primes by 1. Yeah, I think this is right. Probably there's some errors here, but we'll debug them live and we'll learn something. So what should happen here, right now I don't have any code that actually does anything in this. So once these functions are all defined, I'm just going to say, use my old friend if name equals main. And you'll remember this construction from last time. This is some code that we want to run when this file is run directly, but not when it's included into other code. I'm just going to call make more primes 10. So this should make the first 10 primes and put them in a file called primes.txt, but probably it won't. Name path is not defined. Well, that's a great start. Oh, I didn't import my path library from OS import path. Yeah, well, that did run. Let's go see what's in primes.txt, if anything. ebash primes.txt. Ah, it's all the number 2. Well, 2 is prime. 2 is 10 copies of the first prime. That's a good sign. I think what has not happened here is either way, if this is prime or not, I need to increment the value by 1. So we're looking at successive numbers. So let's delete that primes.txt file. Yes. Oops. Let's delete that primes.txt file. Yeah, there we go. And let's rerun our code. All right, now let's see what's in primes.txt, if anything. There we go, the first 10 primes, 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. So in theory, and again, we'll probably break something. So now when I go through my code, right, and I call make more primes of 10, it should say, okay, well, that path to primes.txt does exist. So we'll open it up to read from it. We'll find the value. Ah, okay, so here's where I was wondering about these new lines. So this is going to get the value of the last line of that file, but the last line of that file is this. It's just an empty line because we put 29 and then a new line in there. So I think this is going to fail and tell me I can't interpret new line as an integer. Oh, didn't. Interesting. Reload. Oh, very good. Ah, okay, so here's what happened then, I bet, because we're stripping this. So this looked at that last line and took the new line character off of it, which meant that that last line was no longer the last line. Same thing down here, right? This is the last line, which is basically just a new line character, right? But if we take that off, then the last value is just 71. So now I have the first 20 primes. And if I run this again, I should have, and I reload, I should have the first 30 primes. And if I run this again, but I call make more primes 100, then when it finishes, I should have the first 130 primes, right? So this is a really good pattern to follow if you're doing some of this, like, incrementally. Whenever I have computation time, maybe I'm going to be adding more primes to my file, or adding more anagrams of a set of text, or I'm going to be searching through my maze file for a possible solution, or working on decoding some cryptographic method. Incrementally saving it to a file is a really good way to make sure that you're not losing progress each time you run your code. One last thing I want to show you about this is, so we're using these context managers to make sure that we're writing successfully to the file even if our code doesn't finish correctly. So let's call something like make more primes. Let's do just a too big of a number. Let's make the next 100,000 primes. Don't worry, we won't wait. I'm going to cancel this program in advance. So right now we have 130 primes in our file. I'm going to run our code and then cancel it. But now if I reload, we'll see that I have certainly more than 130. Looks like I only got to, 771 primes. But because we're using this context manager that says, hey, make sure that file opens, does a thing, and it closes nice and cleanly no matter what happens, I'm not losing those intermediate results of my computation, right? Every time I call this with statement, I'm opening the file, maybe doing something to it, and then closing it. I guess I could also have put this with statement in where I only need to actually write out to the file, just save a little bit of computational space. But now, right, so I have 771 primes, and then even though I interrupted my execution early, right, I'm going to execute, cancel again, and when I reload, again, I have more than 771. We're up to 1,312 primes. The 1,312th prime, by the way, is 10,771. For those who are curious, Chris, that one's for you. 10,771 is the 1,312th prime. Maybe we'll let this run in the background a little bit here and just see how many primes we get to. Yeah, so hopefully that makes a little bit of sense, right, is how you would use a file as sort of permanent storage for these long-term or computationally intensive projects, right? We're sort of doing some work and incrementally writing some results to the file so that even if, we can't run the entire program in one go for time's sake, or maybe the program gets interrupted or has an error in the middle, our results are still being saved out to that file along the way. If we close that out there, let's see how many files we get. Yeah, we're up to the 6,330th prime is 63,127. Or I've made an error. Yeah, I think I've made an error. Because oh, no. No, I'm not. Okay, I was gonna say, I thought that number was divisible by 3, but it's not. So hopefully it's prime. Hopefully it's prime. Someone can double check me on that. But yeah, this is the bare bones of writing to a file, and reading, pickling raw data to a file and pulling it back, sending JSON data out to a file and pulling it back like that. This is one of the core skills you need if you do what I recommend is a really cool thing to do in the month of December if you're looking to learn more about code and sort of practice your coding chops. I know, and this is I love this. Been talking to some of the folks out there of like, what are people doing with this information? And some people have a Raspberry Pi and are actively experimenting with it. Some are sort of writing Python on their home computers, and some are just like sort of absorbing general knowledge, knowing that they could like go back and find the details later when they need them. That whole spectrum of things is beautiful and wonderful. If you were looking for like a fun, interesting project that doesn't necessarily require a Raspberry Pi, but you could certainly do with one to brush up on your coding skills in the coming month, I have a recommendation, and that is this. That is the Advent of Code event that will be going into its, I think, 7th year here. It's at adventofcode.com. You see, this one is unlocking December 1st at midnight. They set it up like a coding competition. I don't worry about the competition part personally. But what it is basically a little coding challenge that comes out every day in December. And they are specifically written so that none of them are programming language specific. They're just sort of the kind of challenges you would solve with code. Let me show you, for example, this was the December 1st question from last year. The first part of it is just basically telling us like how they score things. Every day, all 25 days have a 2-part question, and you get 1 star for each part that you solve. So our day 1 question from December 1st of last year was, though it's often winter themed, and last year it was about Santa, having to navigate this star system on his way back home. So our problem from day 1 of last year was we have to find the fuel required to launch a given rocket ship module into space. The amount of fuel is defined to be the mass of the module divided by 3, rounded down, and subtract 2. And just says, so it gives, every project that they give you has some examples. So it says like for 12, you should get the answer 2. 14 should give the answer 2, 1969 should give you the answer 654, and 100,756 should give, gives you some sample answers, some unit tests that you can sort of test your code with, right? Then it says, what is the sum of total fuel requirements for all the modules in your spacecraft? So the input that they give you, and I'm gonna blink away because I think I have to log into my my Google account to do this, to sort of show you what my my version of this looks like. Let's see. What did I log in? Which Google account did I use to log in here? Yeah, okay. Sorry. So when you log in with one of your accounts, you can track your progress. You can say things like, get my puzzle input. So it says, what is the first problem is, what is the sum of the fuel requirements for all the modules of your spacecraft? And it's going to give you a unique text file for your account. So your answers will be slightly different from everybody else's answers because your input is unique. So it gives me this text file that says, okay, I have a module that weighs this much, calculate its fuel. Module that weighs this much, calculate its fuel. Module that weighs this much, and so on and so forth. And my answer for last year happens to be 3,415,076. And that was a very simple program that just said, for each of those numbers in that file, do this calculation. Divide by 3, round down and subtract 2, and add those things up. So this problem uses some very simple programming constructs that are common to many languages. Read data in from a file, some basic math functions, and looping over a thing. And then the next part of the problem was, okay, it's not actually as simple as just doing that math. It should continue to sort of loop in that way, divide by 3, round down, subtract 2, until that number is less than 0, and then add that number to your running total. What would your final answer be then? And in my case, mine was 5 million and change. So now we have a slightly more advanced programming concept on that. We have to read from a file, we have to understand it sort of iterating over numbers, and some slightly recursive functions, like doing something until something else, is that maybe an if-then statement or a while loop or something. And all the problems are kind of like this. They escalate a little bit in difficulty as the month goes on, but they're all written as sort of general purpose programming challenges you could tackle in any language. I really like this structure, and in fact, this is how I learned Python. To begin with. I had never written, that's not true, I'd written a couple little snippets of Python before the advent of code one year, and I just decided, hey, I'd like to learn that language, so I dove in on December 1st. I was like, okay, what am I going to need to know to solve a problem like this? Okay, and I Googled, how do you read from a file in Python? Oh, you use open the file? Great, totally good. All right, some math. Ooh, rounding down, I don't know yet. Google, how do you round down? Oh, it does round down. Okay, good. And so on and so forth. And all along the way, you could sort of teach yourself strategies for problem solving and coding in the language of your choice. If you're interested in brushing up on your coding skills, I highly recommend you take a look at this. There is a subreddit, which is really helpful. To be perfectly honest, some of the challenges are a little bit beyond what I am capable of in terms of determining an algorithm on my own. So things like, a number of them have to do with maze navigation, and the naive way to solve them is sort of iterate through every possible way through the maze. There's not enough time in the universe to check all those possibilities. So occasionally I'd try for maybe an hour and see if I could solve it myself, and then I would go to the subreddit and someone would say, think about the problem in this way. What if you didn't check all of them? What if you only check the connections that are possible right now? And that sparks a hint of oh, that's interesting. Maybe I can go and figure out what that looks like without looking at anybody else's code. Because, of course, I do this in Python. People do it in C or C++ or Java or Haskell or all kinds of esoteric things. So everyone's working in their own languages, but they're all working toward the same problem. I just think it's a really cool time. So I'm going to be doing this again for the month of December. If you want to do it in BASIC, you probably could. BASIC, of course, is an imperative language, so you might have you'd have to come up with your own ways of representing objects, but I think that would be really cool. You could do it in Algol or ASP or COBOL or really whatever you want. The challenges are not language specific. Yeah, cool program. I'm like I say, I'm going to be doing it for the month of December. I encourage you to as well. If you do, please do let me know, because I'd love to follow along with what people are doing. Maybe send me a shout out on Twitter at JeffersGlass, and we'll be continuing to talk more about Python in the month of December. So if you come back in a couple of weeks, talking more about Python data structures and problem solving. If you don't want to miss that, be sure to subscribe and hit that bell. I did not, the words did not taste super good coming out of my mouth. But yeah, it should be a fun December. I'm excited to brush up on some more coding things over the course of time. And I encourage you to take a look at it too. Yeah, that's all we're going to talk about for this evening. I hope to do another casual stream next Sunday night at 7 p.m. here on YouTube. I just got notification right before this stream that the most recent update of parts for the miniature moving light project are through manufacturing and waiting for DHL to pick them up. So if we're very lucky, they'll be here before next weekend and we can assemble the next batch of those. Would be kind of fun. If not, I mean, it is Thanksgiving weekend, at least here in the States, so we may or may not have a stream next week, but I'll get it scheduled. You'll see it in your subscription if you subscribe at that point. Like I said at the beginning, all of the code is on jeff.glass/electronicsbash, and I hope, especially these days as cases are spiking, that you are staying safe out there and washing your hands and hydrating. I hope you all have a wonderful and healthy and warm Thanksgiving. If you are in a place in the world where it is not safe to be gathering with people, I hope you are having your own delicious things and staying away from other people. My personal feeling, I don't... The whole point of this place is to not get too down the rabbit hole, but like, the light is at the end of the tunnel and rapidly growing brighter. If we can all keep each other safe and sane here on the internet where it's safe for just a little bit longer, then I think we can all have a giant, massive party when it's all safe to do so. And we can have the Halloween candy and the turkey and the Christmas presents and at this point probably the Valentine's Day chocolate too, but I'm not complaining, so I think we'll have a good time together. In any case, please stay safe out there. You're all wonderful nerds, and I will see you hopefully next week, if not in 2. Have a good night, y'all. Bye.